Welcome to this eLearn Security video training lesson on writing exploits using the Metasploit framework. In this video, we will see how to write a Metasploit exploitation module that will exploit buffer overflow vulnerabilities affecting the ELS echo server service. The vulnerable server is a simple echo server that listens for TCP connections and sends back messages received by the connected client. The server is listening on the target machine 172.16.5.10 at the 7707 port. Let's try a quick connection to verify how the service works. Let's open a terminal and then the PRI interpreter. The first thing to do is require the socket library. Then we can use the TCP socket class to establish a TCP connection with the service. Now that we have a connection, let's run gets in order to read the server's banner. As you can imagine, with puts, we can send a message to it as well. If we run gets once, we can see that ELS echo server echoes back our messages. Since we know that the server is vulnerable to buffer overflow, let's see what happens when we send a long string to it. To do this, let's execute another connection. As usual, we have the banner. But when we send a big string, we do not see the echo messages from the server, and the connection is no longer available due to a crash. We've already seen how to exploit the vulnerability by writing a simple Ruby script, but now we want to write a Metasploit module to automate the exploitation phase. Writing a Metasploit module will help us to avoid writing custom script every time we want to exploit the ELS echo server. We will also be able to use different payloads or different targets. This is possible because the framework allows us to parameterize the entire exploitation phase and makes our penetration testing activities flexible and fast. Mastering the Metasploit framework and its structure may be very useful for a penetration tester. Before starting, let's move to another workspace. The first thing to do is to find the right file system location for the module we are going to create. This will allow Metasploit to recognize it. The Metasploit directory reserved for private user modules and add-ons is .msf4, which is available in the user home path. So let's go to this directory using the terminal. Since we want to write an exploitation module, we need to go into the modules directory. Right now the folder is empty. Our module will be an exploitation module, so we have to create the folder exploitation and then organize the module into a folder that we will call ELS. So let's start to create all of these directories. Now we have the needed directories. Let's create the module using the command touch ecoserv.rb. Now we have an empty ecoserv module. Let's see what happens if the module content does not follow a valid Metasploit framework structure. Let's insert an A character in the module and then load the MSF console interface. As you can see, we have an error. Our module cannot be loaded because it does not follow a valid Metasploit structure. The easiest way to learn to write a Metasploit module is by taking a look at the code of a module that we use often, and then we can reuse its code to write our own module. For simplicity, we will start by using an empty module skeleton or template. So let's see a skeleton by opening the remote_module_template.rb file on our desktop. As you can see, the first thing that the module does is to require the MSF core library. The module behavior is encapsulated in the Metasploit4 class that must inherit the type of the module from a suitable class. Since our module will try to exploit a vulnerability against remote targets other than the local machine, we will need to extend the MSF exploit remote class. After these two statements, we have a section dedicated to the inclusion of features and utility that we may need in the module. It is done using the mix-in feature offered by the Ruby language. As we will see later on, we will include only the exploit remote TCP since we need a TCP connection to exploit our target service. Initialize is the constructor of the class, and it is used to specify information about the module such as its name, description, author, and some other exploitation information such as the payload options, targets, etc. Thanks to the initialized fields, we can parameterize our module. In this particular exploit module, the last two methods we have to write are check and exploit. The former is used to check if the target is affected by the vulnerability we want to exploit, while the latter holds the real exploit code. Now that you know the module skeleton, let's copy it into our EchoServe module. Now we can reload the Metasploit modules by using the reload command. As we can see, we have no errors. Let's select and use the new EchoServe module. To do this, we can use the usual syntax, which in our case will be use exploit/windows/els/EchoServe. Let's see some information about the module by running the info command. As you can see, we have the information reported in our initialized template, and we can now start modifying them. For example, let's change the author to eLearn Security. Now we can reload the module once again and run info. As we can see, the author is now eLearn Security. Let's now do the same with the other information fields. First of all, let's change the module name. We will call it ELS Echo Server. Let's scroll down a bit and change the description of the module. So when we run the info, we'll get an idea of what the module does. Now that we have changed some of the module information, let's go back into the MSF console and reload it once again. As you can see, after the reload command, we have the right module information. Now it's time to set some other information and options related to the real exploitation phase. The first thing to do is to include the exploit remote TCP class, which provides options and parameters that allow us to specify the target machine. It also provides the methods to perform the TCP connection required for the exploitation. Typing reload, we can now see that we have an error. Indeed, the right class is exploit::remote::TCP. The reload command is useful to check if you are writing the right code. We suggest to avoid developing an entire module without checking its correctness incrementally. Once again, we have an error, and we can see it in the output. So let's go back and edit it properly. As you can see, when no error occurs, the module is loaded. Let's now run info once again. Thanks to the include, we now have two new options, rhost and rport. These options can be used to specify the target service we want to exploit. Since we know that usually the service is available on port 7707, we can set a default value for the rport option. To do this, let's add the parameter rhost in the default option and set it to 7707. As you can see now, we have 7707 as the default rport value. Now we're ready to write the check method. Remember that check is an optional method. You can avoid writing it, but it may be very useful if you want to know if the target service is vulnerable. But how can we establish if the target is vulnerable? Do you remember the banner coming from the service? As you can see, it is ELS Echo Server 1.1, so we can use this banner to establish if the target is vulnerable. Let's move back to the module. The first instruction of our check module will be a connection to the target. We can do this by using the connect method provided by the exploit remote TCP mixin. Note that it will use the rhost and rport parameter as the target. Once the connection is available, we can use the sock attribute, which is an attribute set by the exploit remote TCP mixin. So let's get the banner using sock.gets and save it in a variable named banner. Once we obtain it, we can close the connection with the disconnect command. Now we have to test if the banner obtained by the server is equal to the string ELS Echo Server 1.1. To do this, let's write a simple if statement. Note that the best way to return the results of the test is using the standard Metasploit return values, which is available under the namespace exploit checkcode. So if the test succeeds, we will return vulnerable. Otherwise, we will return a status of safe. Now we can go back in our terminal, reload the module, and use the check method just created. First of all, let's set the remote host to test. As we can see, the option has been set. If we now use check against our target, we can see that it is vulnerable. The last thing to do is write the exploit method. This is the method that will be executed when we type exploit in the terminal. Remember that we are writing an exploitation module, therefore each exploit has a payload that must be used for the exploitation. Metasploit allows us to select different types of payloads thanks to the set payload command. Therefore our module will be a parametric according to the payload to use. We know that the service's vulnerable command is strcpy, therefore the payload must not contain null characters, as that is the string terminator for strcpy. Knowing that, in the initialize constructor, under the payload field, we have to specify the \x00 as a bad character. Please pay attention, we must use the double quotes. Now when we use the set payload command, the framework automatically generates a payload that does not contain any string terminator \x00. The framework allows us to parameterize the target machine type too. For our exploitation, the return value must be a call ESP address, and for Windows XP SP3 machines, we know we can use 0x7c868667. Now that we've set all the required parameters, we can start writing our exploit code. As you can imagine, the first thing to do is to connect with the target service. Remember that it is the service available at our host address and our port. Now let's use print status to print some exploitation information. For example, we have a connection to the service specified by our host and our port. We can print these by reading and using the data store hashes. With this statement, once the connection is established, Metasploit will print the following messages. Also note that the target attribute holds the selected target information. In this case, we will print the target name. Now we can create the entire payload using the buff variable. We know that there are 44 bytes before the return address location on the stack, so we can insert 44 no-ops. Now we have to insert the target return address value set before in the information section. Since we are trying to exploit a Windows machine, we have to use pack with the option V in order to set it as Little Indian. Right after the return address, we have to put some other no-ops. This is because we know that in the stack there are some argument values. Finally, we have to insert the real malicious payload that is available using the payload attribute. We want to insert the encoded payload, which in this case does not contain any \x00. Remember that when the call ESP is executed, the top of stack will contain some no-ops followed by the real malicious payload. Now before sending the payload, we can use the handler method to tell Metasploit to start a handler listening for a reverse connection. It is useful if we set a reverse shell or a reverse interpreter payload. The framework will automatically do the job for us. Finally, we have to send the payload to the service and close the connection. Remember that we can interact with the TCP service using the sock attribute set by the exploit remote TCP class mixin. Now let's move to the MSF console interface and reload the module. Let's set the payload with a reverse interpreter payload. As you know, we have to set some payload options. For example, the L host and the L port, which are the parameters used by the handler method to wait for the reverse connection. Here we can see our IP address. So let's copy it and set the L host in the module. After the L host, we also have to set the L port. Now that the module has been configured, we can try to run the exploit and see if it works. If so, we should obtain an interpreter session. As we can see, we have an interpreter session, so our module works just fine. Note that this way was a very simple module, and there are many other methods available in Metasploit. For example, we can use the make_noops function to generate noops instead of using the \x90. The function generates more sophisticated noops, which are more difficult to be detected by the target system prevention software. Let's try to run this once again. As you can see, we again have a session, so the module is well written. We suggest that you explore some existing modules to better understand how to write them and what are the available options and settings offered by Metasploit. Thank you for joining us.